Hurricane season is just getting started and Tropical Storm Cristobal is already in the Gulf. This week, we'll review some buoy basics and a couple of common gotchas when plotting data on a map. Welcome to another MetPy Monday. Hello, my name's John Lehman, a software engineer for Unidata. This week I want to talk about one of my favorite topics, which is buoy data. And we're going to use Siphon to get some buoy data and make a map. We've looked at buoy data before, but this will be a little bit different map than what we've made in the past. And I want to remind you of some common things that you'll run into when plotting data on map. In fact, over the next few weeks, we'll probably be looking at plotting different data on maps and overcoming some of the common problems that you'll run into. All right, so let's get started with our imports. We're going to import cartopy.crs as CCRS for the coordinate reference system. Cartopy feature as CFeature. We need an as there as well. And remember, these as's are just sort of aliasing the import. It's a common thing that we do to reduce the amount of typing that we do. We're going to import matplotlib.pyplot as plt. Import metpy.calc as mpcalc. From metpy.units, I'm going to import the units registry. And finally, from siphon.simplewebservice.ndbc for the National Data Buoy Center, we're going to import the NDBC class. So if you remember from previous hurricane seasons when we've looked at buoy data, we can either get a time series for an individual buoy, or we can get all buoys at the most recent time, the latest observations. And that's what we want since we're going to make a map. So we're going to get a data frame back from ndbc.latest observations. And again, you can use tab completion there to avoid having to type all of that. And then we'll look at the head of that data frame. So to remind ourselves, we've got a station ID, latitude, longitude, wind speed and direction, gust, wave height, some wave periods, pressure tendency, air temperature, and so on. Not all of these buoys have all of the sensors, but generally there's some combination. The map that I'm going to make is going to have each buoy plotted as a scatter point, colored by air temperature, and then we're going to plot wind barbs on it as well. So it's sort of like a station plot, but not the full thing. The first thing we need to do is make a projection. I'm going to use the Lambert conformal projection. A central latitude of 45, central longitude of -100, and standard parallels of 30 and 60. And again, if you don't remember what all of these different parameters are, I encourage you to look at the Cartopy docs or look at some previous MetPy Mondays where we've talked about projections. I'm going to create a figure. And I'm going to make this a relatively wide figure, I believe. And we're going to create a new axis. And we're going to specify that its projection is our projection proj that we've saved. We can add some coastlines. Remember that 50M is specifying the resolution that we're going to plot this at. So there's our coastlines. And now we're going to add features. So from CFeature.ocean. And again, we can specify a with scale. And we're going to copy and paste that because we want to do the same thing but have land and states. Again, we'll just save ourselves a little bit of typing there. I'm also going to set the extent, just the bounds of my map, to be from -100 to -75 and 25 to 30. Give me a nice view of the Gulf there. And we need to specify that those are in latitude and longitude, also known as Plat Curie. And the hazard of copy and pasting, it's singular add feature. Okay, so there we have our map. And that looks like we're in the right area. I don't see anything too fishy going on. So we're clear to go ahead and start putting data on the map. That's one key thing, I think, is to always get the base map working before you start putting all of your data on. It makes troubleshooting a lot easier if you've got the basics right. All right, so we're going to do a scatter plot. The X is longitude. The Y is latitude. And we're going to color them, or color the scatter points, by air temperature. Again, remember tab completion works. So if we try that, well, what happens? Nothing. So why aren't we getting any data? We remember our map isn't Lambert conic conformal. So these data are not. These data are in Plat Curie, or latitude longitude. So we need to specify that so that the appropriate transformations can happen. So we need to say with transform equals that this is in the Plat Curie projection system. And now we have our data points. But I don't see much contrast in the color. Well, we're going to need to set a minimum and maximum value because the color bar could be getting set by data anywhere on the map. If we're very far up the coast, north, it's going to be a lot cooler than here, obviously. So I'm going to set a minimum temperature of 20 and a maximum temperature of 30. And while we're at it, I'm going to change to the plasma color map. All right, so that looks quite a bit better. We could put a color bar on if we want. I'm going to save a handle to this and call it S for our scatter points. And then I can use fig.colorbar and pass that handle to get a color bar as well. Okay, now what about putting the winds on it? I'm actually going to take the color bar off because I'm more interested in relative temperatures and I like the larger map view here. So for our winds, we're going to use barbs, but those take U and V components, and we have wind speed and wind direction. So we're going to need to use MetPy's calculations, and we're going to have to deal with a couple of tricky things here. But first of all, let's look at the documentation for mpcalc.wind components. So it takes wind speed and direction, and it returns a tuple of U and V. So we're going to unpack into two data series in our data frame, U wind and V wind, what we get out of wind components. And the first thing that it takes is wind speed. The second thing is wind direction. But unfortunately, because of the way units work and data series, there's not really good support in pandas yet for units. We're going to need to get the values from each of these. So just give me the NumPy array of the data. And then I need to attach the appropriate units. And we'll do that here as well, which are degrees. All right, so now we have our U and V components. We're ready to plot our barbs. So again, longitude, latitude, and then our U wind, which is not in tab completion yet because we haven't run this cell, and V wind. Okay, well, we see nothing. So if you remember, it's going to be the exact same problem as we had up here. We need to do a coordinate transformation. But when we do that, suddenly we're not getting anything. We're actually getting an incorrect type. It expected a NumPy array and it got a series. So what does that mean? Well, this is more of pandas having some issues. So we're going to go ahead and extract the values or get the NumPy array from everything that we're passing into barbs. And finally, we get a map. So we can see down here where Cristobal is, some interesting things happening. We've got a little bit cooler temperatures and obviously the wind pattern. And now we've got a simple map that we could add on to with pressures or anything else that we want to keep an eye on what's happening in the Gulf from the data buoy network. And all you have to do is rerun this same notebook at any time to get the most recent data. I hope that you found this useful, and I'll see you on next week's MetPy Monday.